Next thing we'll do is difference of squares. So here's the formula we'll use. A squared minus b squared is a plus b times a minus b. And again, there is the depiction in shapes. So here's an example. If we had t squared minus 49. Well, this is hopefully a lot easier to recognize than the perfect square trinomials. It's a difference because I've got the minus sign, and it's a difference of squares because t squared is just t squared and 49 is 7 squared. So if we look at how that works in the formula, if I have a squared minus b squared is a plus b times a minus b. So I'll just put a t wherever there's the blue and a 7 wherever there's the red. And that would factor as t plus 7 times t minus 7. I check it using FOIL and it checks. So let's do another one. Try this one on your own. Okay. Again, it's a perfect square, or difference of squares, because it's 3x squared minus y squared. Put everything where it goes. Put 3x in the first spots and y's in the second spots. And I've got my factorization. It's 3x plus y times 3x minus y. Okay, what about this one? Is it a difference of squares? Well, it's a difference. I've got the minus. And each of the numbers and each of the variables is a perfect square. So I think of the first one as being 10a squared. Think of that blue as just being a set of parentheses. And again, the red is another set of parentheses. So it would factor as 10a minus plus 7b and 10a minus 7b. And it checks out, just like we would expect. Okay, how about this one? How about n squared plus 25? Well, they're both perfect squares, so let's see if it's not a difference of squares, but let's see if it'll still work. If we just ignored it and kept going, if I put n in the first spots and 5 in the second spots, what happens when I check? Well, my middle terms cancel, which is good because it leaves me with a binomial, but the plus 5 times the minus 5, that gives me a negative 25. I don't want a negative 25, I want a positive 25. Remember, to get a positive 25, I'd either have to have 2 positives or 2 negatives. So let's try both of those. Well, if I have n plus 5 times n plus 5, then my middle terms won't cancel. Similarly, if I have n minus 5 and n minus 5, my middle terms won't cancel. So that brings us to the fact that a sum of squares does not factor. A sum of squares is prime. There's no way to get that middle term to cancel. Okay, this next one, 8z minus 2z cubed. Now we've gotten a little bit lazy. What do you always have to do first before you start factoring? Look for a greatest common factor. So if we pull out the 2z, we'll have 4 minus z squared. Okay, that's a difference of squares. So it's 2 plus z and 2 minus z. Then I'd want to put my greatest common factor out front. 2z times 2 plus z and 2 minus z. Now we're going to do this one two ways because I have told you to put things in descending order. This time it didn't matter. With binomial, you don't need to. With trinomials, you do. So, and there's my check, so it does work. If we do it the other way, if we put it in descending order, now my greatest common factor is still 2z, but I'm not going to factor out a 2z. What will I factor out? I want to factor out a negative 2z because if I have a leading negative, I always factor that. Now I have z squared minus 4, which is again is a difference of squares. So I have z plus 2, z minus 2, and I'd put my greatest common factor out front. Those answers do look different, but they are both equally correct. It doesn't matter which one you have. And there's my check.